we are going to discuss about the eigenvalues and eigenvectors of a matrix. So we will start with the definition. Let A equal to Aij be a matrix of order n by n. That is a square matrix of order n. A number lambda is called an eigenvalue of A if there exists a non-zero column matrix X, which is x1, x2, so on, xn. Since we are considering n by n matrix, so the column matrix is of order n by 1. Suppose if you consider a 3 by 3 matrix, then the non-zero column matrix is 3 by 1 matrix, such that Ax equal to lambda x. Then x is called an eigenvector of A corresponding to the eigenvalue lambda. Since Ax equal to lambda x, so this means A minus lambda I of x equal to 0. And we know that x is not equal to 0. That means at least one of this xi is not equal to 0. So the system has non-trivial solution. That means determinant of A minus lambda I equal to 0. This is called the characteristic equation. This equation is called the characteristic equation. And its roots are called the characteristic roots or eigenvalues, or sometimes it is also called proper values and also called latent roots. There is another formula for finding the characteristic equation, which is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0, where s1 is some trace of a matrix, that is sum of main diagonal elements, and s2 is sum of minors of main diagonal elements, and s3 is determinant of A. If you consider a 3 by 3 matrix, then this is the characteristic equation. Lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0, where s1 is trace of a matrix, s2 is sum of minors of main diagonal elements, s3 is determinant of A. If you consider a 2 by 2 matrix, in that case the characteristic equation is lambda square minus s1 lambda plus s2 equal to 0, where s1 is trace and s2 is determinant of A for 2 by 2 matrix. Now we will solve the problems. Example, find the eigenvalues and Eigen Vectors of the matrix A equal to 3 minus 4 4, 1 minus 2 4, then 1 minus 1 3. The solution. So the characteristic equation is lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. So for that we first find s1, s2, s3. We know that s1 is trace of A, that is sum of main diagonal elements. So this is the main diagonal elements. Now sum these two, these values. What are that? 3 minus 2 plus 3. So which is equal to 4. And s2 equal to sum of minus of main diagonal elements. So which is equal to the minor of the first element a11 is nothing but you remove this first row and first column, find the remaining determinant, that it is minus 2 4 minus 1 3 plus next the minor of this element. So for that you remove this column and this row, then remaining determinant is 3 4 1 3, and then plus remove the next column and row, that is the minor of this element. Remove this row and this column, then remaining determinant is 3 minus 4 1 minus 2. So which is equal to, now find the 2 by 2 determinant. So for that the cross multiplication of these two, this minus 2 into 3, so minus 6 minus 1 into 4, minus 4 already 1 minus, so plus 4 plus 9 minus 4 plus minus 6 minus of minus plus 4, this one. So this is equal to minus 2 plus 5, then minus 2, so which is equal to 1. Next find the s3 value. So s3 equal to 3 times, find the determinant value. So to find the determinant value you can expand through any row or any column. Now I am expanding with the first row, so that is 3 times determinant of, remove the corresponding row and column, this column and this row, and then find the remaining determinant. Minus 2 4 minus 1 3. Next minus the next element I am going to expand through first row, so this minus 4 into determinant of, remove this column and this row, and then find the remaining determinant, that is 1 4 1 3, and then next element is 4, this 4, and then remove this column and row, then remaining determinant is 1 minus 2 1 minus 1. Now simplify this, then you get 3 times minus 6 plus 4, then minus of minus plus 4, 3 minus 4 plus 4 into minus 1 plus 2, then you get minus 6. So the characteristic equation is lambda cube minus s1 lambda, s1 is 4, 4 lambda square plus s2 lambda, s2 is 1, so lambda minus s3, so already one minus is here, minus 6, so minus of minus plus 6 equal to 0. So the characteristic equation is lambda cube minus 4 lambda square plus lambda plus 6 equal to 0. Now solve this cubic equation. So for that, you first write the coefficients 1 minus 4 1 6. Okay, write the coefficient of cubic term, that is 1, and write the coefficient of square term minus 4, then write the coefficient of linear term 1, and then constant is 6. Now try with arbitrary element, trying with minus 1, and put 0 always here. Then simplify this, 1 plus 0 is 1, then 1 into minus 1 is minus 1, and then simplify this, minus 5, and then minus 5 into minus 1, 5, then 1 plus 5 is 6, and 6 into minus 1 is minus 6, so 0 you are getting. So minus 1 is one of the root. Now I am trying with 2, so put 0 always here, then 1 plus 0 is 1, 1 into 2 is 2, minus 3, minus 3 into 2 is minus 6, so you are getting 0. If you getting 0 at the end, then only that is the root, otherwise you have to start with another arbitrary number. This is trial and error only. So next I am trying with 0 3, put 0 here, then 1, 1 into 3 is 3, so 0. So we are getting 0 here, so therefore the eigenvalues are minus 1, 2 and 3. Now we need to find the eigenvector. Let x equal to x1, x2, x3. Since we are considering 3 by 3 matrix, so the eigenvector is 3 by 1 vector, a 3 by 1 matrix, column matrix. Let x be a eigenvector corresponding to the eigenvalue lambda. Therefore a minus lambda I into x equal to 0. That means we know what is a. A is this matrix. So now find a minus lambda I. So a minus lambda I. So that means a is what? A is 3 minus 4 4, 1 minus 2 4, then 1 minus 1 3, minus lambda I. So lambda into I is 1 0 0 0 1 0 0 0 1 into the matrix x, the column matrix x1, x2, x3 equal to the 0 matrix. So 0 matrix also here, column matrix 0 0 0. Now if you simplify this, then what you may get? 3 minus lambda minus 4 multiply with x also. 3 minus lambda into x1 minus 4 x2 plus 4 x3 equal to 0. Similarly x1 minus 2 minus lambda x2 plus 4x3 equal to 0, and then finally x1 minus x2 plus 3 minus lambda into x3 equal to 0. So this is the system of equations. So name this equation by 1. Now we have 3 lambda values, minus 1, 2 and 3. So substitute one by one. First one is case 1. lambda equal to minus 1. Then 1 becomes, here substitute lambda equal to minus 1. Then what do we get? 4x1 minus 4x2 plus 4x3 equal to 0. Next is x1, then minus 2 minus of minus 1. So minus x2 plus 4x3 equal to 0. Next x1 minus x2. Here also if you put the minus of minus 1, then you get plus 1. 3 plus 1, 4 plus 4x3 equal to 0. Here the second and third equations are same. So consider first two equation. Now we are going to use the cross multiplication rule. So for that you consider two different equations. I am considering first two equation. In that first equation also you can rewrite this equation as means you divide by 4 because it is all are multiplied by 4. You can divide by 4. So consider from this equation, that is x1 minus x2 plus x3 equal to 0, and consider the second equation, that is x1 minus x2 plus 4x3 equal to 0. Now solve these two equations by cross multiplication rule, which is you have to write like this: x1 by determinant of, you remove the x1 column, then you find the determinant value of the remaining coefficients matrix, that is minus 1, this one minus 1, and then this coefficient is 1, and then this coefficient is minus 1, and this coefficient is 4, which is equal to minus x2 by, always put minus for all the problems, minus x2 by, remove the x2 column, then the remaining determinant is 1 1 1 4, which is equal to x3 by, now remove the x3 column, then find the remaining coefficient determinant. So 1 minus 1 1 minus 1. Now simplify this, then what do you make it? So which is equal to x1 by, here the cross multiplication, minus 1 into 4 is minus 4, and then minus of minus 1, so plus 1, which is equal to minus x2 by, here the determinant value is 1 4 is 4 and 1 1 is 1, so 4 minus 1, which is equal to x3 by, and this cross multiplication is minus 1, and then minus of minus 1, so minus 1 plus 1, so that means you get x1 by minus 3 equal to minus x2 by 3 equal to x3 by 0. If you multiply by minus 3, then you get the eigenvector x1 equal to 1 1 0. If you multiply by minus 1, if you want, you can write one more step, that is x1 by 1 equal to x2 by 1 equal to x3 by 0. If you multiply by minus 3, then you get this one. So therefore x1 is the eigenvector 1 1 0. Similarly, in this system, substitute lambda equal to 2, because next eigenvalue is lambda equal to 2. Then if you substitute lambda equal to 2, then you get this system. Now consider two different equations. Here first two equations are same, So consider these two equations, then use the cross multiplication rule. So you will get the next eigenvectors. So first you remove the x1 column, then x1 divided by the remaining determinant is minus 4 into 1. So minus 4 and then minus 1 into 4 plus 4, which is equal to x2 by minus x2 by. Always put minus, then remove the x2 column, then the remaining determinant. So here 1 into 1 1, and then 1 into 4, so minus 4 equal to x3 divided by. So now remove the x3 column, means you remove this column, then find the remaining determinant. So then what you may get? So this cross multiplication, right? Multiply the coefficients only. So 1 into minus 1, so minus 1, and then multiply these two coefficients. So 1 into minus 4, already 1 minus, so plus 4. So if you simplify, then what do we get? So this implies x1 by 0, x2 by minus 3, minus minus get cancelled, so plus 3 equal to x3 by 3. Now if you multiply by minus, not minus, multiply by 3, then x2 equal to 0 1 1 is the next eigenvector. Similarly, if you substitute lambda equal to 3 in this system, then you get this equation. Then here also, if you consider first two equations or last two equation, then you get the x3 vector. So this implies x1 by. So here also all three equations are distinct. If all three are distinct, then you can consider any two equations. Either you can consider first two or last two, or first and last, anything. So remove the x3 column, then what you may get? So 0, multiply these two coefficients, and then minus, multiply these two coefficients. So already one minus is there, so it is plus 4, which is equal to x2 by. Now remove the x2 column. If you remove the x2 column, then multiply these two coefficients. So always put minus in front of x2, then multiply these two coefficients, then what do you make it? 0, and then multiply these two coefficients, that is minus 4, which is equal to x3 divided by. Now remove x3 column, then what do you make it? If you remove this x3 column, then minus 1, and then multiply these two coefficients, then minus 5, already 1 minus, so plus 5. So now if you multiply by 4, then what do you may get? So x1 by 1 equal to x2 by 1 equal to x3 by 1. Therefore the eigenvector x3 equal to 1 1 1. So if there is a 3 by 3 matrix, so there should be 3 eigenvalues, and correspondingly there should be 3 eigenvectors. Thank you.